equations. Today we're going to look at graphing radical equations. First, let's talk about what's referred to as the parent function. So every movement, shift, stretch, compression of what we're going to be looking at is based around this equation, y equals the square root of x. Now, what we're looking at is y equals a times the square root of x minus h plus k. Each one of these letters, the a, the h, and the k, all do something differently to my graph. And that is what we're going to look at right now. Let's start off just addressing this part, the part that's under the radical. All right, this is what's referred to as a horizontal shift. All right, the original equation, y equals square root of x, has nothing added or subtracted to the x underneath the radical. So if there is a number added or subtracted to the x underneath the radical, that means there is some type of shift left or right. All right? So from a horizontal shift, h determines the horizontal shift. So let's just look at how that h affects my graph of this equation. So y equals x plus h. All right? Now, notice that this is x minus h. All right? So what this means is that, or the way we're going to think about this is that if it says minus h, then it shifts right. If it says plus h underneath the radical, that means shift left. So let's say I have y equals x minus 2. So in this case, we have x minus 2. So does it say minus h, minus h? It does, but that means it goes to the right 2 units. All right, if I have y equals x plus 3, this says plus 3, and we said that underneath the radical, if it says plus h, plus 3, that is to the left. And in this case, it would be 3 units. So understand that we're going the opposite direction of what it looks like it should go. So if it says x minus h, we're shifting to the right, plus h, we are shifting to the left. When we look at the vertical shift, notice that I have plus k. K is not underneath the radical. So the only one that is different than what it appears is the h, and that is because it is underneath the radical. So plus k directly tells me how many units up and down I'm going. If it says plus k, so in this case, plus k means up, minus k means down. All right, if it says plus k, I move up. It says minus k, I move down. So if I have y equals if I have y equals the square root of x plus 4, since it says plus 4, and I know that plus k goes up, then this is going up 4 units. If I have y equals the square root of x minus 3, notice the bar for the square root does not extend all the way over the 3. So this is not underneath the radical. So this is minus k. Minus k means down. So this would be down 3 units. So my shift is down 3. So h underneath the radical goes the opposite of what its sign would indicate. And k on the outside of the radical goes the actual direction in which it appears. Legend has it that Mike Tyson offered a zookeeper $10,000
to fight a gorilla.
Now we're going to look at a vertical stretch slash reflection. All right. If we know that the base function or the base equation looks like y equals square root of x, also referred to as the parent function or parent equation, now we're looking at what happens with that a that was directly in front of the radical. Notice this is a times the radical. There is no plus or minus, okay? In this part, a is 1. There is no vertical stretch. There is no reflection. All right, we want to identify what would make it stretch and what would make it reflect. All right, so the first part is if the absolute value of a is greater than 1, it is a vertical stretch. So I'm stretching my graph higher. So what this does is that whatever x is, it would be multiplied by a, and if the absolute value is greater than 1, that means my graph would stretch. My y values would get larger than what they would be if a was not bigger than 1. All right. If the absolute value of a is less than 1, so in other words, between 0 and 1, all right, I would have a vertical compression. It would squish my graph down. So instead of having, if x is 4, y is 2, if a was something other than 1, it could make that value either be bigger or it can make that value be smaller. And we'll look at examples of that, how it works on Desmos. So the last one is if a is negative, then that reflects the graph over the x-axis. I have my original equation typed into the first line, and this red part on my graph, this red line, is the graph of y equals the square root of x. Let's investigate horizontal shift. So y equals the square root of x minus h. All right, I'm going to put in a slider so we can see what happens. So when I look at my h values, as they get bigger, so 2.9, this would say x minus 2.9. All right, so that's why it appears that x minus a number is my horizontal shift to the right. All right, so notice as I plug in different numbers for h, my graph either shifts to the left or to the right. The shape of the graph doesn't change, it just shifts to the left or right. Okay, now let's say I want to look at the vertical shift. So I have y equals the square root of x plus k. Let's toss a slider into here. If I pick a bigger number than 1, it slides up. If I pick a smaller number or a negative number, it shifts down. So if I look at it, my graph, as I, add or subtract a k to the end, my graph is literally just shifting up and down on the y-axis. All right, let's take a look at what happens for the a that would be out front. So absolute value of a, or just a square root of x. All right, so as a gets bigger, this graph is going to shift, or it's not going to shift, it's going to stretch vertical. All right, so when I'm at 4.1, notice how much it has stretched up. It actually changes the shape of my graph, unlike the other two. And as I get even bigger, it just stretches more. Now, when I start getting small, the closer I get to 0, the closer I get to 0, my graph gets small. So notice when a is 0.25, it is very small. It has compressed closer to the x-axis. Now, when it shifts to negative, you see how it flips underneath, or flips over the x-axis. All right, so here's what it looks like just with the slider just moving, you can see how that A value affects and changes what my graph looks like.